So here the question says a long conducting wire having a current I flowing through it bent into a circular coil of capital N turns, then it is bent into a circular coil of small n turns. Okay. The magnetic field is calculated at the center of the coils in both the cases. You have to find the ratio of the first case to the second case, right? So again, this is a straightforward formula based question. So if you have a circular coil, okay, with I current flowing through it, the magnetic field at the center is given by the formula not I upon 2 times the radius, right? If R be the radius of this coil and I is the current flowing through the circular wire. Okay. If there are n number of turns, you simply multiply by the number of turns in the coil. Okay. So you simply multiply by the number of turns. So this will give you the magnetic field at the center, right? So for both the cases, we'll try to find out the magnetic field ratio at the center using the formula, right? This is the formula for N turn and current I radius R, right? The given wire is of some fixed length, let's say L, right? In this case, turn it in a circular coil of N turns, capital N turns, then what is the radius going to be? Then what is the radius going to be? Let's say Rn is the radius. Okay. So I can write 2 pi Rn, that is the circumference of one coil, right? Times capital N should be L, right? And in the second case, the same wire of the length L is now turned, there are N turns now, small N turns. In this case, the radius is going to be, I can write 2 pi. Radius is, let's say, Rn, small n, times n is going to be L, isn't it? So this is true and this is also true. So from here we get the radii. Okay, we get the radii of the two coils that we have. In the first case, this is the radius, and in the second case, the coil that we'll get will have this as the radius. Fine. Now let's try to find out the ratio of the magnetic field. Okay, I can say B for n turns to that of B with small n turns is going to be mu naught. The current is the same, N upon 2 times Rn. That is the radius of this coil, right? Upon mu naught I small n upon 2 Rn, right? This is the ratio. So when you'll simplify this, you'll get this to be, this thing here will come out to be mu naught I n upon 2 Rn, that is the radius in this case, times 2 Rn upon mu naught I small n, right? This cancels, this cancels. Okay, this 2 also cancels. I am left with n upon Rn, n and Rn, right? This thing here. Now you see this one and this one we had, right? You just divide one by the other. You get the ratio of n upon small n. Okay. This thing you divide by this should be equal to this divided by this, that is 1. That means this upon this will give you Rn upon Rn times n upon n is 1. That means from here I can say that small n upon n is equal to Rn upon Rn, isn't it? That means R capital N upon R small n is equal to small n upon n. So if you substitute the value here, you are going to get n square upon n square. The ratio is capital N square upon n square. If you substitute this value, okay, for R small n upon R capital N, it is going to be capital N upon n. So this becomes the answer. Option number 3 here. Okay. Thank you.